Welcome to a lesson with Dr. Powell. Let's briefly discuss when we might want to use the different tests that we have when we're testing for convergence or divergence. For the ratio test, and the root tests are often the first go-to tests that we might look at. The ratio test is often good when we have things like factorials, or we have like a number raised to some power in n, so a specific constant raised to the n. The root test is good often when we have some expression raised to the nth power, some expression in n. So we have like n to the n or 2n plus 1 to the n or something like that. The root test is often good. Sometimes these things are intermixed though, and in that case, maybe the best way to go is something else. For instance, what if you have like n factorial over n to the n? Well, here you could even think of this as being like n over n times n minus 1 over n times da 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 da, like n minus 2 over n times, we have n n's on the bottom, n things on the top all the way down here. Notice that all of these fractions are less than 1 themselves, or at least less than or equal to 1. So we could maybe just look at the last two, 1 over n and 1 over, yeah, 2 over n. Those are the last two things we're multiplying at the tail end. And since all of these guys are fractions less than 1 multiplied onto this, that means that this itself is actually less than or equal to 2 over n squared, which we know converges by a p-test, which will say that that converges. Notice that all that we did was use some kind of clever comparison. So that is a viable solution if to use comparison. If you really can't get this test working or this test, just go straight to comparison tests. But first, kind of the first thing to try or look at generally is a ratio or root test using this little rule of thumb. Factorials and numbers like 5 to the n or something like that kind of call for a ratio test. And something like this calls for maybe a root test. So, for instance, something like 5 over 3n squared plus 2, either all raised to the nth power or a part of it raised to the nth power, or even if this would be fine. Even if you had something like this, 5 to the n, that would be okay too, because really number to the nth power can be tackled very nicely by the root test. A factorial, though, often is best for a ratio test. Okay. And when combined with numbers to the n, that's good for ratio. Now, in this situation, if the ratio test can also eat up things like this, like a polynomial in n over a polynomial in n, or even with various, or maybe just a sum of various powers. They don't even have to be in a whole number of powers. They could be other types of powers here going on. This is perfectly fine, but in the ratio test itself, this really will always become, in the limit, this idea will always turn out to limit to 1. So really the only thing that really will matter in the ratio test is the factorials and numbers to the nth power. That's really going to give you what your ratio is. The polynomial part that we get in here is really going to not even matter. All right. So what happens then if these tests are inconclusive? If you actually successfully were able to apply them, and if we couldn't, we went somewhere else, especially like a comparison to a p-series. So let's see, let's just get that straight. We can compare to a p-series, or we can compare it to like a geometric that we know that converges, or we can compare to anything that we can integrate at all. And if we can do an integral comparison, that's a good way to go. So kind of at the beginning, we look at ratio, root, and if neither of these seems very viable, and it's hard to work with, then we could jump right here comparing to something else like a p-series or geometric series or just something we can integrate. That's good. So first start here. If it doesn't seem viable, come here. All right. Now, what if we actually went here and we found out the test was inconclusive? So limited to one and means inconclusive. Then what do you do if the test is inconclusive? All right. Then you try something else. Maybe you try something for, so these are uh, an, maybe an integral comparison test. So you go right back to here. In fact, maybe we can just make the arrow go there. So at the very beginning, we can see if we really can't do these, then we just jump here. But if we can do these, that's great. We go to inconclusive and we notice, then kind of this is where we go. Now, keep in mind that this right here is a test for absolute convergence for the series of absolute values. And these are also tests for absolute convergence. So, but what if we want a conditional convergence result? So we first come here for absolute, and then we can go over for conditional result. And there's two things we can do for conditional convergence. We can either use an alternating series test, or we can look at a pattern and find out a formula for the nth partial sum, and then take a limit. So we have various options. And I think this pretty much sums up the basic routes that we take. So first, ratio and root tests, they're absolute value tests. And if we can't seem to do that, then we jump here. But if we did this and it was inconclusive, then we go back here again. Now remember, this is absolute. Now, if we want conditional though, then we'd come over here. And we go to either alternating series test, or we get a formula for the nth partial sum by looking at a pattern, and then we take a limit of that to see if the sum converges or diverges. Thanks for watching.